Chapter 24 is comparing two means. So we did one proportion z-intervals and z-tests. And then we did two proportion z-intervals and z-tests where we compare two proportions. And then we did one sample t-intervals and t-tests where we had one mean. And now we're doing two sample t-intervals and t-tests where we're comparing two means. I mean, I told you this would get really repetitive, and it is. So we're just doing confidence intervals today, though. So I'm going to keep writing this stuff down until I pummel it into your memory. So what are the 3 steps to a confidence interval? See, you guys all tell me that, and then on quizzes and tests, you don't do them. So I don't know what else to do.
Mechanics simply don't have enough time for
I typically do the conditioning, and if I don't think I get one wrong, so pretend I get into it and
It must be what it is. People must panic because I'm like, you guys can tell me until the day of the quiz or the test. All right, now for the mechanics, I keep going back to the formula sheet because that is what you have on the actual exam. So on the formula sheet, it says a confidence interval is a statistic plus or minus a critical value times the standard deviation of the statistic, which sometimes you have to estimate the standard error and sometimes you don't. It depends on the scenario. The proportions we don't have to estimate. If we have p, right? If we have p hat, we have to estimate, get the standard error. Same thing with means. If we had sigma, we wouldn't have to estimate. But if we don't, we have s, we have to estimate. It's fine. Okay? So here is the quote-unquote formula for our confidence interval, right? If we're talking about two means, and think of it just like we did proportions, what is the statistic if we're talking about two means, do you think? What was the statistic when we did two proportions? Excellent. The thing minus the thing. For proportions, it was p hat 1 minus p hat 2, right? You have two proportions. Well, so then what do you think the statistic is going to be for means? The mean minus the mean. But is it going to be, what symbols are we going to use here? We're talking about the statistic. Bar, right. Our book uses y bar. I normally write x bar just because I'm in the habit of doing that. Whatever variable with a bar over it is a mean, right? So we have x bar 1 minus x bar 2. Again, the easiest way to compare two things is to find the difference between them. Plus or minus, because we're talking about means, what's our critical value going to be from? The t distribution. And we'll talk about the degrees of freedom associated with that in a second. Because there always has to be degrees of freedom associated with that, right? And then we have the standard deviation of the statistic, and I'll go through and write that all out in a second as well. All right. That formula is also on the AP formula sheet because they all have been, right? I gave you the 1 proportion standard deviation, 2 proportion standard deviation, 1 sample standard deviation, and 2 sample standard deviations. They're all in those boxes on the formula sheet, right? So you have those to use. Questions so far? All right, just a reminder, the statistics are the x bars. You guys had that this time, and the parameters are means. They are not u's. I keep arguing with people about it. They are not the letter u. They are m's as in mean. The Greek letter mu. Mu. Like spelled out, it would be mu. Almost like moo, but mu. Okay. So, first step of a confidence interval is the condition. It's the same conditions you have for a 1 sample test. You check independence first, right? Is everyone within group 1 independent of each other? Is everyone within group 2 independent of each other? If you have 2 groups, though, what else do you check? The groups are independent of each other. So that still applies since we have 2 groups. Randomization. Was randomization employed somehow? Right? Did they do something to randomly assign people to groups? If not, is it a good representation of people in those groups? 10%. It says we usually don't check this condition for differences of means. That's nice. Usually. A lot of the time with means questions, it doesn't make sense. The one we're going to do today in class doesn't make sense. I mean, you could write it, but it doesn't really make much sense. And then for one sample, we talked about the nearly normal condition, and it's all about sample size. So you check a histogram, or you check a box plot, or you check a normal probability plot, or something, if you can, to see if the data or the distribution is nearly normal. And if so, that means the sample size is large enough to use all these methods. Now, if you have two groups, you have to check one for each. All right, you can't just check the histogram for group 1 and then assume group 2 is good. All right? If the histogram for group 2 is terrible, then you don't move forward. Okay? So check everything for both groups all the time. Do not put things together. On the last test, we did proportions. A lot of you guys checked your conditions, and let's say there was, I don't remember this on the test, I'll just make some stuff up. Let's say there was a group of 700 people, all right, total. You had to take 2 independent samples, all right? So there was 700 total people, but the first sample was 350 women, and the second sample was 350 men, right? You cannot put those together to check the condition. So you cannot say that 700 is less than 10% of all people. You have to say that 350 is less than 10% of all women and 350 is less than 10% of all men, right? You can't say that 700 people were randomly chosen, blah, blah, blah. You can say that the 350 women were randomly chosen from a group of women and the 350 men were randomly chosen from a group of men, right? Don't stick them all together. Don't do that. Any questions about the conditions at the moment that you can think? You guys are getting pretty good at this. Box plots are awesome to compare 2 groups of data. Why are box plots better use for comparison? I think Jacob was on the right track. He's making a lot of mumblings over there. You can put them side by side. You can see them, right? You can't put a histogram on top of a histogram in your calculator. Then you can't see anything that's going on. You can't put a normal probability plot on top of a normal probability plot. That gets really confusing, which dots are which, right? You can't, however, turn on 2 different box plots in your calculator and look at them simultaneously and be able to make comparisons. All right, so box plots work better in a pinch because you can see them directly side by side. Questions about that? All right. So 2 sample t-interval. Again, these names are super fancy. 2 sample t-interval. We have, like I said, y bar 1 minus y bar 2, or x bar, whichever. Mean 1 minus mean 2. Plus or minus the margin of error. And the margin of error is your t statistic times the standard error, which again, we'll talk about in a second. I've listed all the other intervals you know. If you start trying to memorize all these individual procedures, you're going to be lost all the time. That's why I keep trying to show you the same pattern. If you would just be able to fit your statistic to the pattern, you'd be good to go. Now, in this scenario, for our 2 sample t-interval, t has to be defined by some degrees of freedom, right? Correct? Now, the degrees of freedom is based on what? Or has been based on what? N minus 1, so it was based on the sample size, right? Now, with a 2 sample t-interval, technically speaking, we're not actually using the t-distribution. It's a different distribution, and it's super close to the t-distribution. So we have to adjust some things. So because of that, the degrees of freedom formula is this hot mess down here at the bottom of the screen. And no one's got time for that. So because of that, this is the one time, singular one time so far, that I will let you get away with doing things in your calculator because you have to. All right? So we're going to use our calculator, because I showed you way back when we did 1 proportion, z-intervals, that your calculator can actually calculate the interval for you. I said that is a good way to check your answer. And it is. It is not a good way to rely on in the middle of a problem, because then you don't do any of the mechanics and you miss a bunch of points because you just write an interval down. Okay? But in this case, you have to use your calculator because there's no way to calculate the degrees of freedom. And since there's no way to calculate the degrees of freedom, we can't calculate t. Like when you go to type in inverse t, you don't have the degrees of freedom, so you can't do it. So we're just going to let the calculator do it for us. Okay? It's not that hard. Everyone good so far? So then the standard error, we haven't talked about that formula yet. We know it's y bar 1 minus y bar 2. We know we can't actually subtract standard deviations. We can't actually add them either. We have to add variances and then take the square root. So it takes you through how they all got to this. But this here in this box is on the formula sheet. And since we don't actually know sigma, because sigma is the standard deviation of the population, so we probably don't have that information, we're going to estimate with S, and that's going to be okay. Questions about that? And the only thing left will be the conclusion. You can use that same template you've been using. I think it's easier to directly compare and say one group is higher than or lower than the other in some way. That just sounds better than saying that the difference in the means is in this range. But we can practice that when we do an example. Any questions? All right. I'm going to do my one example. It says a man who moves to a new city sees that there are 2 routes he could take to work. A neighbor who has lived there a long time tells him Route A will average 5 minutes faster than Route B. The man decides to experiment. Each day he flips a coin to determine which way to go, driving each route 20 days. He finds that Route A takes an average of 40 minutes with a standard deviation of 3 minutes, and Route B takes an average of 43 minutes with a standard deviation of 2 minutes. Histograms of travel times for the routes are roughly symmetric and show no outliers. A says find a 95% confidence interval for the difference in average commuting time for the 2 routes. So what's the first step? Conditions. I am not going to write them all out because we will be here all day, but we will talk through them. So, for your conditions, independent. This one's a little funky, we can talk about it. Are the 20 days that Route A is driven independent of each other? Should be. Are the 20 days that Route B is driven independent of each other? Yes. Are the 2 groups of days or 2 routes independent of each other? Should be. Is randomization employed? Yes, they flipped a coin. He flipped a coin each time to determine which route to take. Right? Okay? 10%, this is where this is kind of funky. So this is when you can make a judgment call if you think you're going to use it or not. In this case, it would be 20 days is less than 10% of all days the route could be driven. So you could say that. It's kind of funky. So do you have to say it? No. Talking about people, that makes more sense, like a population. But in this case, the population is days, and that's weird. All right, and then the nearly normal condition. We don't have data, and we don't have graphs, but they do tell us the histograms of travel times for the routes are roughly symmetric and show no outliers. So, because the histograms are roughly symmetric, the nearly normal condition can be satisfied, so the sample sizes are large enough. Everyone go with the condition. Then we write a sentence. Because the conditions are met, I can construct a 2 sample t interval. Excellent job. If you weren't given anything besides sample sizes, you should base it on sample size. And 20 may or may not be great. So you would need, hopefully they're going to do something. Today in the homework, I give you 2 different types of questions. One that gives you actual graphs, and one that gives you all of the data so you can make your own graphs. Generally, that's what's going to happen on the AP test. They're not going to leave you hanging with a decision, like a judgment call on if it's a large enough sample size. All right, so done the conditions. The next part's the mechanics. Now, again, we're going to use our calculator, but that does not excuse you from setting up the question. You still need to write down in the formula what it's going to look like. This is why I'm saying this. I'm saying this for a reason. On all those free response rubrics, where you guys have to do a hypothesis test or a confidence interval, I make you write the sentence and I make you show your work for two reasons, all right? On the rubric, it always says somewhere, it's tangled up in one part of the question. On the rubric, it says you get a point or part of the points or something for naming the interval or test by name or formula. If you write the sentence and you write the name, you get the point. That's why I keep telling you to do that. Let's say you forget. You have to show your work anyway, but if you just show the formula filled in, that also suffices because you've shown the formula, so that you know what you're talking about. Okay? So I'm making you do both, so that way there is always something to catch you just in case. All right? On the quizzes and tests on mine, in my class, I'm taking points off for not writing that sentence. Because I'm trying to get you in the habit of doing both so that on the AP exam, when you have a moment and you can't remember the name of the test, then you can still show the work and be okay. Okay? So the mechanics of this. We have, again, x bar 1 minus x bar 2 plus or minus some t critical value that we're not going to be able to figure out. Okay? Times the standard error. Because we're going to estimate because we don't have population standard deviation. Now, it's totally up to you. Just like it was with the proportions, you can do whichever proportion you want first. You can do whichever mean you want first. I don't care. So would you rather do route A minus route B or route B minus route A? Okay, Jacob says A minus B. So we're going to do it that way. So I'm going to fill in what I can, and then I'm going to do everything else in the calculator. So the mean of route A is 40 minutes. The mean of route B is 43 minutes. Plus or minus, again, this critical value that I can't figure out, times the square root of standard deviation of A is 3 minutes over 20 days, so 3 squared over 20. And the standard deviation of route B is 2 minutes, so 2 squared over 20 days. Everyone know where all those numbers came from and why they're put there. It doesn't matter. It would have been positive that way, yes. Yeah, so it's fine. It's all good. A minus B is perfectly fine. Min's going to be mad about it because it's not positive, but it's fine. All right. So at this point, you could do some of this if you wanted to. You could do 40 minus 43. You could find the standard error, but we still couldn't compute the interval if you had those. So I'm just going to leave it right there. All right, so in your calculator. I showed you where to find these a while ago, but it's been a while. So go to Stat and scroll over to Tests. In here are all the hypothesis tests you would need and all the intervals you would need. So you can check all of your answers in the calculator. I don't show you all of these at the moment because then you'll use them and you don't actually know what you're doing. So when we start reviewing for the AP exam, I will go through, or when we get closer to the end of all this inference stuff, I will go through all of them with you. But we've done a lot of these that are in here. So if you, again, if I try to show you in the calculator, then you just do that part and you don't actually write anything down. And then on the free responses, you're not used to doing it. So I always go to the calculator last. All right, in this case, though, we have to do it. So we're going to do it. So we're looking for a 2-sample t interval. Don't do the test because we're not doing a test. So 2-sample t interval is down here, 0. Now, it has 2 options. The first option, if you highlight data, hint data, is the data option. This means that in the question, you were given 2 lists of raw data. Okay? If you were given 2 lists of raw data, you should have already done 1 variable statistics to figure out the means and standard deviation so you could fill this in how I did. But then you don't have to estimate or anything. Your calculator will do it all for you. So if your route A information was in list 1 and route B information was in list 2, you would do that. You would put your confidence level. We never pool anything. for a confidence interval, so that's not a thing. Don't worry about it. Okay? But it'll calculate the entire interval based on just the two lists of data. You don't have to do anything. Do we have two lists of data, though? No. So the other option is the stats option, in which case you have to know the mean and standard deviation and the sample size for both groups. Okay? So we do have all that. It always does 1 minus 2, just like I wrote, x1 minus x2, x bar, right? So make sure that whatever you wrote matches whatever you put in the calculator, or you'll get it backwards. Does that make sense? All right. So we're going to do route A first. So the mean was 40, and the standard deviation was 3, and there was 20 days, then 43, and 2, and 20. We're 95% confident. Make sure you write that as a decimal. It shouldn't ever be clear, so there should always be a confidence level already in there. Just remember to put it as a decimal. We're not pooling because we don't do that right now, and we hit enter. And it thanks. It gives you the interval, and it gives you the degrees of freedom. You need to report the degrees of freedom because you didn't have it before. Right? So our interval is negative 4.64 to negative 1.36. The degrees of freedom is approximately 33. Now the rest of the stuff on that screen is everything you reported to the calculator, so it's giving it back to you. Okay, so that's not new information. Okay, everyone handle that. Yeah. So again, all the intervals we've done are in there, so if you're going to start checking your answers, please do. It does not excuse you from doing all the extra work. Okay. Questions so far? All right. So almost done. We need to now write a conclusion. I'm going to write it two ways. I'm going to write the way that I think sounds better, and then I'll write the way that maybe you probably write it. I don't know. So I am 95% confident. You always start it that way. That route A takes 1.36 minutes to, not takes the wrong word. That's a big eraser. Whoa. Yes, sorry. 1.36 minutes to 4.64 minutes faster than route B. That's a direct comparison. That's exactly what the interval shows, right? Yes. You guys will probably write it, I am 95% confident that, oh, this needs to say on average. Because we're talking about averages, so make sure I always talk about the average. Okay. 95% confident that the average difference in route time is between 1.36 and 4.64 minutes. It's not wrong. It doesn't directly relate the two routes. It just says the difference in the times is somewhere in the interval. Does it make sense that in this scenario we had to write everything as positive? Should for all of these, right? If you're going to average something from average height or average weight, does it make sense to have a negative? So just make sure you think about the context of the question it's asking about. Questions about that? Conclusions. All right. Then part B says, should the man believe the old-timer's claim that he can save an average of 5 minutes a day by always driving Route A? People are shaking their heads no. That's good. But you're supposed to explain.
5 minutes outside.
Because 5 minutes is not an interval or it's outside the interval, right? So it looks like he could save 1.3 minutes to 4.64 minutes on average, right? So he can save some time, but 5 minutes seems to be an over exaggeration how much time he could actually save. It's not in our interval. Questions about that?